Happy Friday, everyone. So today we're going to do lesson 80 for our math. And today we're going to be looking at ratio problems. Now this is something that you've really already done when you've been trying to get similar denominators with fractions. However, instead of doing that, we are working with ratios. So lesson 80, it's on page 413 of your math book. And the topic is using a constant factor to solve ratio problems. So to get started, the way this lesson is taught is it uses a diagram that looks similar to this. On one side, you have what we would say the ratio numbers are, and then on the other side, you have what the actual number will be. So let's just write this example down. The ratio of boys to girls was 3 to 2. If there were 8 girls in the class, how many boys were there? So right here we have several different numbers and we have to figure out what to do with these numbers. So the ratio of boys to girls was 3 to 2. So this first sentence right here tells us that 3 and 2 is going to go in one of these ratio boxes. We just have to figure out which one. So I'm going to label boys on top and girls right here on the bottom. And it really doesn't matter which ones you put on top or bottom technically, but because boys is mentioned first, I'm just going to put boys first in my chart and girls secondly in my chart. So 3 represents the boys, because boys is mentioned first and 3 is the first number that is mentioned. So I'm going to put a 3 in that ratio box. And then 2 represents the girls, because girls is mentioned secondly, and 2 is the second number that is mentioned. So I'm going to put a 2 right there. And notice that I'm staying in the ratio column. Now I have one other number that I have to deal with, and that's number 8. So if there were 8 girls in the class, how many boys were there? So it's telling me that the actual number of girls in the class is 8. But it doesn't tell me how many boys there are. It wants me to get that. So this is where I need to come up with what times 2 gives me 8. Just like you do when you're trying to get the same denominators in fractions. So what times 2 gives me 8? The answer is 4. So then I would multiply that 3 by the 4 as well. So 3 times 4 equals 12. And 12 is my answer. So let's do another example. And also, this 4, they call that a scale number in your book. Okay, so let's do another one. Let's maybe even look at this example that I have. And I can post this practice sheet as well under our notes. That way you don't have to write it all out, but you can print it off and know what I'm talking about. So let's just do number 1 right here. So number 1, actually let me just get a different sheet of paper. That'll be easier. So practice number 1. Okay, I'm going to first start out as drawing my box. I'm going to put ratio on one side and then actual number on the other. And for this example, it's talking about flower color. I think that was one of my cats that just knocked over something. Sorry about that, y'all. So the ratio of red flowers to white flowers. So I have red and I have white. In the garden was 4 to 3. So 4 is going to be the ratio number for red. So I'm going to put my 4 there. And then 3 will be the ratio number for white. So I'm going to put a 3 right there beside white. Next I have this number, 30. If there were 30 white flowers, how many red flowers were there? So it's telling me that there are actually 30 white flowers in the garden. So I'm going to put a 30 right here, an actual number. And I'm trying to get how many actual red flowers there are. So again, I have to mentally ask myself, what times 3 gives me 30? And that answer is 10. So then I'm going to also take that 10 and multiply it by the 4. And 4 times 10 is, of course, 40. So 40 is my answer. Let me see if there's any other complicated examples that I should go over. I'll give y'all a second to write that down if you would like.